Hi class, let's take a look at problem 4a. In problem 4a, they want us to use the quadratic formula. So the quadratic formula or the quadratic that you're given has to be in this form, meaning that it has to be set equal to 0. And this particular formula, it's going to solve all actual quadratics, assuming that you're evaluating them in that form. And here's the basic idea. So if you apply the quadratic formula, it's going to solve all the cases except that the no solution, it's going to end up as x is equal to some sort of a plus bi. These are your complex numbers. And then you will be able to get solutions that happen to be a single one, so it'll show up as repeated, or two separate solutions. And the idea is as long as you have a set equal to 0, we should be fine in the evaluation. Some of your numbers may get really large because, well, the actual numbers given could start large. So I'm referring to this portion here. So you may need a calculator to evaluate that because you could get a value that is extremely large. Now, here you actually see the solutions. I basically graph the equation so we could see what we're going to be expecting. So in this particular case, as we solve by using the quadratic, we have to first identify a, b, and c. So the values of a are equal to 1, b is equal to 7, and c is equal to -8. And then we're simply going to evaluate, and we're going to plug it in. X is equal to -b plus or minus the square root of b squared minus 4ac divided by 2a. And then at this point, we're plugging them in. So x is equal to -7 plus or minus the square root of 7 squared minus 4 times a is equal to 1, c is equal to -8. All over the values of 2 times a, in this case, we're going to end up with 2 times 1. As you can see, as we are plugging in the formula, it starts to look a little bit messy, but it's not that bad on this one. 7 squared is just going to be 49, so we're not looking at extremely large values. So at this point, I'm just going to say that x is equal to -7 plus or minus the square root. We end up with 49, and then technically plus the values of 32 all over the values of 2. And x is equal to -7 plus or minus the square root. 9 and 2 is going to be 11. So I'm looking at 81. I'll check that in a minute. Yep, we're looking at the square root of 81. Also, there's a chance because of the numbers that this number doesn't simplify easily, and you're going to have to find, well, perfect radicals to simplify it. In this case, we end up with an integer. So we can separate this, or let me rewrite it as -7 plus or minus, well, 9 divided by 2. And let me separate it since we're going to end up with two solutions. So x is equal to -7 plus 9 divided by 2. Or x is equal to -7 minus 9 divided by 2. X is equal to, in this case, we're going to end up with 2 divided by 2, which is 1. And that's going to represent this solution here. That represents technically x is 1 and y is 0, or your first solution. And the second one, or x is equal to -16 divided by 2, or -8. So our solutions, by using the quadratic formula, it's going to give us x is equal to 1 or x is equal to -8. And you can see the -8 here in the graph. That's x is equal to -8. Both of those y values are 0 since we're finding the intersections. And that's actually it for this problem. Once again, it gave us solutions of 1 and -8.